In this video, I'm trying something new, trying a new way to record this, so hopefully the quality of video is a lot better than it has been in the previous few videos. But I'd like to go over an example where the motion of a particle is given by the equation right here. X is equal to t cubed minus 9t squared plus 24t minus 8. And we're asked to do two things. First, determine when the velocity is equal to 0, determine at what time the velocity is equal to 0, and B, determine the position and total distance traveled when the acceleration is equal to 0. Part A is pretty straightforward. Velocity is the derivative of x, the derivative of the position, and we're given the position right here. So velocity is equal to dx dt, and we know x is this equation right here. So if we take the derivative of x of t cubed minus 9t squared plus 24t minus 8, and we take the derivative with respect to t, we get the equation is equal to 3t squared minus 18t, this is 24t, plus 24. The 8 goes away because there is no t, so it just goes away. And this is the equation for velocity, 3t squared minus 18t plus 24. We want to know when velocity is equal to 0, so when does velocity equal to 0, we can set the velocity equal to 0. So this is equal to 0. And now we have this equation. We have 3t squared minus 18t plus 24 is equal to 0. We can simplify this. We can take a 3 out, so we can get t squared minus 6t plus 8 is equal to 0. And we can factor this and get t minus 4, t minus 2 is equal to 0. And we can set both of these equal to 0 and we can get t is equal to 4 and t is equal to 2. And both these times are in seconds. So 4 seconds, 2 seconds. And what this means is at time equals 2 seconds, when the time is equal to 2 seconds and the time is equal to 4 seconds, the velocity is 0. There's no rule that says the velocity only has to be equal to 0 at one point in time. It's actually equal at 2 points in time in this case. So that's part A. So this is the answer for part A. Part B wants us to determine the position and total distance traveled when A equals 0. So we know that this is an equation for velocity, and the acceleration is the derivative of velocity with respect to time. And this is our equation for velocity. So the derivative of 3t squared minus 18t plus 24 with respect to time, dt. We can do this out, and we will get this derivative is 6t minus 18. Next, we have to figure out when our acceleration, at what time is our acceleration equal to 0. So we take the same steps as we did with the velocity. We take the equation we just got for acceleration and we set it equal to 0. So I should probably write this here again. 6t minus 18 is equal to 0, so t is going to be equal to 3. So at time 3 seconds, our acceleration is equal to 0. And determine the position in total distance traveled. So we take 3 seconds, the time we just found, and we put 3 seconds into this equation for x. So the position at 3 seconds is equal to x equals 3 cubed minus 9 times 3 squared plus 24 times 3 minus 8. And this should be 10. And this is going to be the problem specified that this was in inches. So at 3 seconds, when our acceleration is 0, we have moved 10 inches. Or we're at position 10 inches. The total distance traveled, we have to break this problem up into a few more steps. We have to look at the time from where's x at time 0. At time 0, time equals 0. Because our velocity changes at 2 seconds, we need to look at t when it's equal to 2 seconds. And we have to look at t when it's equal to 3 seconds, because that's when our acceleration is equal to 0. Now, this value of t that we chose right here, t equals 2 seconds, is not an arbitrary value of t. We chose this value because if we look at a graph of acceleration, or a graph of velocity, and we have a time, and this is 0, this right here is 0, when velocity crosses the 0 point, doesn't matter if it's coming up or if a velocity is coming down, when it crosses the 0 point, the sign of the velocity is going to change. In this case, it's going to change from a minus to a plus. And in this case, it's going to change from a plus to a minus. And this is significant because this means our position, and this is a positive x direction, our position, when it has a positive velocity, is going to go like this, but when it has a negative velocity, is going to come back the other way like this. So it goes with a positive velocity this way, and with a negative velocity it goes the other way. Now this is going to affect the total distance traveled, because we'll see how that affects that in a minute. So at time equals 0, we plug 0 in for our equation for x, and we get 0 cubed minus 9 times 0 squared plus 24 times 0 minus 8, and we get minus 8 inches. So at time equals 0, we start at a position of minus 8 inches. So if we have a line right here, and this is t equals 0, this position right here is minus 8. Now at time equals 2, we plug in 2 cubed minus 9 times 2 squared plus 24 times 2 minus 8, and we get 12 inches. So at time is equal to 2, we get 12 inches all the way over here. And it's a positive 12 inches. Now at time is equal to 3, we already figured this out, we have 10 inches. So this is equal to 10 inches. And we get this number, we figured it out right here. So at time is equal to 3, is equal to 3, we have a positive 10 inches. So what does this mean? This means our particle moves along the x-axis this way till it gets to 2 seconds, and then at 2 seconds it comes back on itself and it comes to this point right here at 10. So our total distance traveled is -8 or 12 minus a -8. So it's the total distance is going to be equal to delta x1, the change in our first time period, plus the change in distance in our second time period. And delta x1 is equal to the magnitude, because we're only interested in the total distance traveled, of 12 minus -8, and this is equal to 20 inches. And delta x2 is equal to the magnitude of 12 minus 10, or 10 minus 12, doesn't matter. And this is equal to 2 inches. So in total it's delta x1, 20 inches, plus delta x2, 2 inches, is a total travel of 22 inches.